All right, section 5.8 in our textbook talks about energy and chemical reactions. Specifically, we're going to look at heat energy, and there's two main terms I want you to know. The first is exothermic reaction. And a exothermic reaction is a reaction that releases heat. And it's a pretty common reaction. A lot of reactions we know of release heat. One of my favorite ones, though, is when I go skiing, I take those little hand warmers with me. They're really nice if on a cold day, but really all this is an exothermic reaction. And on the inside of the pouch, what you have are little pellets of solid iron. It's nice and cheap. And when you open it up from the plastic container, it will react with oxygen in the surrounding air. And in this process, it will essentially rust and make iron 3 oxide, which is Fe2O3. And this is a solid, plus you get this heat out of the reaction. That's what makes this exothermic. So like I said, this is just a hand warmer. There are other hand warmers too, the ones where you can microwave them and reset them. Those are a completely different reaction involving crystallization. One other thing to remember is we need to bounce this. So we need to make sure we have the same number of atoms on the left and right. So if we look over here, we can do some guessing and checking. So for example, I could put 2 here. And I'd say, well, now we've got 2 irons on each side, right? 2 irons here, 2 irons here. But now let's check oxygen. Over here, I've got 3. Over here, I've got 2. The only way to fix this is to put a 3 over here and a 2 over here. But when we do that, we've bounced the oxygens, but now our irons aren't bounced. We've got 4 irons over here, so I go over here and put 4 over here. All right, I did want to make a note about all of these. And this is one that's not really discussed in the book, but I do think it's important to remember. If you think about making a bond, if you make a bond, you're going to release heat. Basically, you're going to release energy. However, if you break a bond, that's going to be the opposite. You need to take energy or absorb energy here. And let's even just change this to release energy. Sorry, I know this may mess up your notes. And this is really important to figure out. And in fact, you can go look at tables and you can calculate the net sum to know if a reaction is exothermic, like we're seeing above, or endothermic, which is what we're going to cover next. Okay, so let's just make a note here. And let's go into endothermic reactions. These are essentially the opposite. And an endothermic reaction absorbs heat. This is one thing that really bugs me when we talk about hot and cold in day-to-day life, so I'm just going to make a note here. A lot of times people will think that their air conditioner is creating cold air. That's not true. Instead, what your air conditioner is doing in your house or car is it's transferring the heat from inside your house to outside your house, meaning we can't generate coldness. So you cannot generate coldness. Coldness is really just the absence of heat. You can only absorb heat, which is essentially what your air conditioner is doing. So let's take a look at a common one. So calcium carbonate, CaCO3, is a solid. It's a mineral. And if you apply heat to it, you can get a chemical reaction to occur whereby you make calcium oxide, which is just called lime. Sometimes you use it in your yard to change your soil. And you release CO2. Which is a gas, right? So the main thing here is that we're getting heat on the reactant side, meaning we need it for the reaction to take place, whereas with an exothermic reaction, heat is a byproduct of the reaction. All right, I hope that makes sense, but let me know if you have any questions. And like I said, if you go on and take more chemistry, you can calculate the net sum to know whether or not a reaction falls in this upper category or in this lower category. But for this course, we're not going to get into that. I just want you to know the basic terms. All right, good luck studying.